Hey everybody, welcome to the shop. Today we're going to get our hands dirty, metaphorically speaking of course, with mechanical bearings. These ingenious little components are everywhere in our mechanical world, quietly and efficiently allowing machines to move. Welcome to our comprehensive guide on mechanical bearings. Whether you're a seasoned engineer or just curious about the inner workings of things, understanding bearings is key to appreciating the magic of motion. Today, we'll explore various types of bearings and their general specifications. We're going to break down the differences between ball bearings and roller bearings, delve into the world of thrust bearings and linear bearings, and even touch upon the often overlooked plain bearings. So grab your safety glasses and let's get started. Alright, let's start with the basics. Ball bearings. You know those little metal balls you find in fidget spinners? Those are ball bearings. These simple yet effective components are found in everything from skateboards to hard drives. The magic of ball bearings lies in their ability to reduce friction by replacing sliding motion with rolling motion. This means less wear and tear, smoother operation and increased efficiency. Plus, they're relatively inexpensive to manufacture, making them a popular choice across a wide range of applications. Now let's talk about the heavy hitters in the ball bearing family, deep groove ball bearings. These bad boys are designed to handle both radial and axial loads, making them incredibly versatile. You'll find them in everything from electric motors and pumps to conveyors and even your car's wheels. What makes them so special? Well, their deep groove raceways allow for higher load capacity and better high-speed performance compared to standard ball bearings. Next up, we have angular contact ball bearings. These bearings are specifically designed to handle combined loads, meaning they can take both radial and axial forces simultaneously. But here's the kicker: they can handle significantly higher axial loads than deep groove ball bearings. This makes them ideal for applications where thrust forces are a major factor, like machine tools, high-speed spindles, and even rocket engine turbo pumps. Yeah, they're that tough. Now, if you're dealing with purely axial loads, then thrust ball bearings are your go-to solution. These bearings are designed to handle force in one direction only, along the axis of rotation. Think of them as the specialists of the ball bearing world. You'll find them in applications like gearboxes, automotive clutches, and even rotating stools. Alright, let's shift gears and talk about roller bearings. Unlike ball bearings, which use balls for rolling elements, roller bearings utilize cylindrical, spherical, or tapered rollers. This design change allows them to handle significantly higher loads than their ball bearing counterparts, making them ideal for heavy-duty applications in industries like mining, construction, and aerospace. First up in our roller bearing lineup, we have cylindrical roller bearings. These beasts are designed to handle extremely high radial loads. We're talking tons of weight. They excel in applications like gearboxes, rolling mills, and heavy-duty machinery where radial forces are the primary concern. Plus, their simple design makes them relatively easy to manufacture and maintain. Next, we have spherical roller bearings. These ingenious bearings have a spherical outer raceway, which allows the bearing to self-align. This means they can tolerate misalignment between the shaft and housing, making them perfect for applications with potential shaft deflection or misalignment issues. You'll find them in vibrating screens, mining equipment, and other heavy-duty applications where shock loads and misalignment are common. Now let's talk about tapered roller bearings. These bearings are designed to handle both radial and axial loads simultaneously, just like angular contact ball bearings. However, tapered roller bearings can handle even higher loads due to their tapered roller design. This makes them ideal for applications like automotive axles, transmissions, and other heavy-duty applications where combined loads are present. Moving on to needle roller bearings. These bearings are characterized by their long, thin rollers, which resemble needles, hence the name. This unique design gives them a very small cross-section, making them ideal for applications where space is limited. Despite their compact size, needle roller bearings can still handle high radial loads, making them a popular choice for applications like gearboxes, transmissions, and compact machinery. Alright, let's take a break from rolling elements and talk about plain bearings. Unlike ball and roller bearings, plain bearings don't have any rolling elements. Instead, they rely on a sliding contact between two surfaces, typically separated by a thin layer of lubricant. This simple design makes them incredibly reliable and low maintenance, perfect for applications where low speed, high load capacity, or resistance to shock and vibration are crucial. One of the most common types of plain bearings is the bushing bearing. These bearings consist of a cylindrical or flanged sleeve called a bushing that's inserted into a housing to provide a wear-resistant surface for a shaft to rotate in. Bushing bearings are typically made from materials with low friction coefficients like bronze, PTFE or graphite. You'll find them in everything from hinges and doorknobs to suspension systems and even aircraft landing gear. Now let's talk about linear bearings. Unlike the previous bearings we've discussed, which facilitate rotary motion, linear bearings are designed to provide smooth, low-friction linear motion. They achieve this by using rolling elements, either balls or rollers that move along a track or rail. Linear bearings are essential components in a wide range of applications, from CNC machines and 3D printers to sliding doors and medical equipment. First up in our linear bearing lineup, we have ball linear bearings. These bearings use balls as rolling elements, which provide smooth, precise linear motion with low friction. Ball linear bearings excel in applications requiring high speed, high accuracy and low noise, such as CNC machines, robotics and automation equipment. So next we have roller linear bearings. These bearings use cylindrical or needle rollers as rolling elements, which provide higher load capacity and stiffness compared to ball linear bearings. Roller linear bearings are ideal for heavy-duty applications requiring high load capacity, high rigidity and good shock resistance, such as material handling equipment, packaging machinery and heavy-duty industrial automation. Finally, let's talk about mounted bearings. These bearings are pre-assembled units that combine a bearing with a housing, making them incredibly easy to install and maintain. Mounted bearings are available in a wide variety of configurations, including pillow blocks, flange units and take-up units to suit a broad range of applications. You'll find them in conveyors, agricultural equipment, fans and countless other industrial applications. Well, there you have it. We've explored a wide range of mechanical bearings, from the tiny ball bearings in your fidget spinner to the massive roller bearings used in heavy machinery. Thanks for watching. We hope this guide helps you understand the different types of mechanical bearings and their specifications. Bearings are essential components in countless machines and devices we rely on every day, quietly and efficiently enabling motion and making our lives easier. Don't forget to like, share and subscribe for more informative content. And be sure to let us know in the comments which bearing blew your mind the most. Until next time, keep on building, keep on exploring and never stop learning.